In this lesson, we're going to look at finding the area of a parallelogram. So, first of all, let's look at finding the area of a rectangle. This should be review, but what we're going to do is look at it and look at the sides of the object that we're looking for. So, if we had a rectangle that was simply one square unit, it would be 1 unit tall and 1 unit long. So basically we would say 1 times 1. So 1 times 1 is going to give us the area of this unit, which of course is just 1 unit. So that's pretty easy. Now if we made this object longer, so it's now 1 unit tall, but it's 2 units in length, now we'd be looking at 1 times 2 units in length, which would give us our area of 2 units. And that makes sense because we've got 2 units in our picture here. Next, if we decided to sort of make it another unit taller, then it would be 2 units by 2 units. And so here we've got 2 units on the height times 2 units on the length, and 2 times 2 will give us 4, and again this makes sense. We have 1, 2, 3, 4, and you can continue to do this. So for example, if we extended it a bit further, so it's now 3 units long, we're going to find that we have a height still of 2 units times a length now of 3 units, and that's going to give us 6 square units. And as you can count, 1, 2, 3, 4, 5, 6, that still works. So this basically works for any pattern you want to do. If we had little manipulative square blocks, we could do this for sort of any rectangular shape. So whether it be a square with sides and height the same, or a rectangle where the sides and heights are different, it'll basically work for any rectangle. And you've learned about this in previous classes, so this should really be review. But the formula that we use for this is we call this the area, and we'll say the area of a rectangle in this case is equal to its base. So basically how long this bottom part is. And remember, the top and the bottom are the same length. So this is 2 long, this is 1 long, this is 3 long. So the area is equal to the base times the height. And so for any rectangle, we can basically just multiply the length of the base times the height of the object, and we will get the area of that object. So this works for all rectangles, but why does it work for parallelograms? So just a reminder of what a parallelogram is. A parallelogram is any four-sided object where the opposite sides are parallel. So for example, if I drew an object, so if this line and this line were parallel, and this line and this line were parallel, that would be an example of a parallelogram. So that line and that line are parallel, as are those two lines. They're not parallel to, this one's not parallel to this one, but this one's parallel to this one, and this one's parallel to this one. So it's basically any four-sided object, and because everything's parallel, that also means that this length is the exact same as this length, and then this length is the exact same as this length. So the where we're getting to with this is that when we've got some object, so it's a parallelogram, that it doesn't seem to apply to the same sort of rectangle process that we did here, because it sort of looks like it's been smushed over, and and maybe has a different area now. And it, to some extent it does, but I'll show you how this formula can still be used to find the area of a parallelogram. So first of all, let me draw one that's a little bit bigger so that it's easier to see. So if we had again, this line and this line are parallel, that line and that line are parallel, and these lines are also the same length. These lines are the same length. So one thing that's important is when we're talking about it, the base stays the same. So we're still going to call this the base, similar to what it was here on any of our rectangles. So that's still the base. But the height's a little bit different. We don't want to use this line here or this line here because that's not actually representing the height of the object. The real height of the object is actually right here. And that's a right angle. So the actual height of the object is here because that's how tall it is. It's not really that the length of this line doesn't represent the actual height of the object. Now, this still is sort of weird. Why does this still work with base times height giving us area? Well, I'll show you a really neat little trick about this. So if you can imagine that this part here is sort of like a triangle. And if we took that object, if we took that triangle and just sort of moved it and put it over on this side, we wouldn't really be changing the area of the object. It would still be the exact same. So if we just took that triangle and put it over here, and now since we've moved it, the erased more than I wanted to there. But since we've moved it, this height has still remained the same. And this base, well, it may not look like it's remained the same, but remember we had this exact same length was over here. We've just moved it to the other side. So it really is the same length. It's just been sort of moved over. So this base is still the same. And now, as you can see, we actually have a perfect rectangle. So that's why this formula here still works. So whenever you have any sort of a parallelogram, so any object that looks like this, as long as you can find the height of the object as a straight up and down sort of height. You can't have an angled height here. It's got to be perpendicular to the bottom, straight up and down height. Then you can basically find the base times the height is going to give you the area of that object because of this little trick that I showed you here. So I hope that that's been helpful, and whenever you're looking for the area of any parallelogram, including rectangles and squares, but also any sort of other parallelograms, you can always use the formula of multiplying the length of the base times the length of the height.